At 23 minutes past 1 in the morning, on the 26th of April, 1986, a man in the control room of reactor number 4 at Chernobyl reached across the panel and pressed a button labeled AZ5. AZ5 was the emergency shutdown. It was the button you press to make a nuclear reactor stop, the last line of defense, the one thing in that entire building designed to save everybody in it. 4 seconds later, the reactor began to tear itself apart. That's it. That's the mistake. The worst nuclear disaster in human history was triggered by 2 men hitting the emergency stop. Now listen carefully, because this is the part that almost every documentary gets wrong. They were not being reckless. They were not cutting corners. They were not showing off. They were doing the single most conservative thing an operator can do in a nuclear power station. They were shutting the machine down at the end of a job. The button killed them. And the men who designed that button had known it could do exactly that for 3 years. To understand how you get from a routine shutdown to a hole in the roof of Europe, you need 3 things: a safety test that had already failed once, a phone call from Kyiv that pushed the whole thing into the dark, and a warning written in 1983 that reached the men who mattered and then quietly disappeared. Let's start with the test. Chernobyl reactor number 4 had a problem that every reactor on Earth has. When you shut a reactor down, it doesn't stop being hot. The core keeps producing decay heat for days. If the cooling pumps stop, the fuel cooks itself, so the pumps have to run no matter what, including in the exact scenario where the plant loses all outside electricity. The station had diesel generators for that, but diesels are slow. They took roughly a minute to come up to full load, and in that minute, the pumps had nothing. So somebody had an idea. When a turbine loses steam, it doesn't stop instantly. It coasts. 50 tons of spinning steel, winding down, and a coasting turbine is still a generator. Could the dying turbine power the pumps for that 1-minute gap? That was the entire test. That's what everybody died for. Here's the first thing that should bother you. The test had been attempted before. It had been run at that station previously, and the electrical output from the coasting turbine fell away too quickly to be useful. It failed, so they fitted new voltage regulators and scheduled it again for the routine shutdown in April of 1986. Here's the second thing that should bother you, and it's bigger. Everyone involved treated this as an electrical test. Turbines, generators, voltage, the non-nuclear half of the plant. The test program was written without proper coordination between the team running the experiment and the people responsible for the nuclear safety of the reactor. The safety precautions built into the program were inadequate, and the operators were never warned that an electrical experiment carried any nuclear risk at all. Sit with that. The men in the control room did not know that what they were doing could destroy the reactor. Nobody had told them, because the people who wrote the program didn't think it could. That's not a mistake in the control room. That's a mistake 3 organizations upstream, on paper, months earlier. The test program also called for isolating the emergency core cooling system so it wouldn't trip and interrupt the experiment. That system was shut off at 2 in the afternoon on the 25th and stayed off for the entire duration. It didn't cause the accident. Assessments afterwards concluded it barely affected what followed. But remember it anyway. It tells you the temperature in that building. The attitude was that nothing is going to happen, so let's remove the thing that stops things from happening. Now the part that turns a bad day into a catastrophe. The shutdown began at 6 minutes past 1 in the morning on the 25th of April. Power came down in stages. By 3:45, they were holding at 1600 megawatts thermal, roughly half load, waiting to descend further. Then Kyiv called. The electricity grid controller for the region asked the plant to keep supplying power. Demand was high. The city needed it, so the reactor sat at half power for the rest of the day, and the experiment was postponed. That Single phone call is the hinge of this entire story. Without it, the test runs on the day shift. It runs with the engineers who had spent weeks preparing for it, who had read the program, who knew what the plan was, standing at the panel with the sun up. With it, the test slides past midnight and lands on a night shift that came in expecting to babysit a reactor through a routine cooldown. They inherited an experiment somebody else had written, half executed, at the worst hour of the day for human judgment. Power reduction only resumed at 10 past 11 that night. Shift change was at midnight. Hold that thought. We're 4 hours from the explosion, and so far not one person has done anything wrong. 28 minutes past midnight. The reactor is coming down through 500 megawatts thermal. Control is handed from the local regulating system to the automatic one, and the power collapses, not to the target. It falls off a cliff, all the way down to about 30 megawatts thermal, roughly 1% of the reactor's rated output. For 35 years, the standard version of this story said an operator fumbled the handover, pushed the wrong setting. Human error. That version is dead. The 1992 review by the International Atomic Energy Agency, INSAG-7, explicitly walked it back. It noted that the Soviet State Safety Commission found no operator error as such. The commission referred to an unknown cause and an inability to control the power. Dyatlov, the deputy chief engineer standing in that room, maintained the system simply hadn't worked properly. Whatever caused it, the consequence was chemical, and it was merciless. When a reactor runs, it produces iodine-135. Iodine-135 decays into xenon-135, and xenon-135 is a poison. It swallows neutrons and strangles the chain reaction. At full power, the reactor burns that xenon off as fast as it's made. Balance, but drop the power hard, and the balance breaks. Iodine keeps decaying. Xenon keeps building. The reactor fills up with a substance that is actively trying to shut it down. The operators tried to bring the power back, and every single thing they did to fight the xenon pushed them one step deeper into the trap. They pulled control rods, more rods, more rods. By 1 in the morning, they had clawed the reactor back to about 200 megawatts thermal and stabilized it. That's it, 200 out of a design output of 3200. Low, dangerously low, in a reactor that hated running low. And to hold it there, they had emptied the core of its safety margin. There's a number in nuclear operations called the operating reactivity margin. Think of it as how many control rods you still have available to shove into the core if things go wrong. Your brakes. Chernobyl's rules said 15. Never go below 15 equivalent rods. Calculations done after the accident found that at 1, 22 and 30 seconds, roughly 70 seconds before the button was pressed, the operating reactivity margin was 8, not 15, 8. So the obvious question is, why did nobody stop? Because nobody could see it. The operating reactivity margin was not a dial on the wall. It was not a warning light. It was not wired into any protection system that could have shut the reactor down automatically. Assessments afterwards were blunt about this. The definition itself was imprecise. Its importance appears to have been poorly understood by the operators, and the actual value was not conveniently available to the men at the panel, and was not built into the reactor's protection system. There was a hard safety limit. There was no instrument for it. There was no interlock enforcing it. You had a speed limit and no speedometer, and no brakes that engaged when you broke it. That is not an operator error. That is a design decision, and it gets worse because the number 8 isn't just a violated rule. In an RBMK reactor, the number of rods in the core changes the physics of the core itself. With that few absorbers left, the reactor's response to steam went from manageable to actively hostile. Which brings us to the thing that actually blew the roof off. Water in a reactor core does two jobs. It carries heat away, and it slows neutrons down so they can cause more fission. In most Western reactors, if the water boils into steam, you lose the neutron slowing. The chain reaction weakens, and the reactor damps itself. Physics puts out the fire. The Foundation Juice puts the RBMK was different. It used solid graphite to slow the neutrons, and water mainly for cooling. And in this design, water also absorbed neutrons, so when the water boiled, you didn't lose your moderator, you lost an absorber. More steam meant more power meant more steam. That's called a positive void coefficient, and at 200 megawatts with 8 rods in the core, reactor number 4 was sitting deep inside the region where that feedback loop was strongly positive. The machine was primed to run away, and the men holding it were not told that such a region existed. But even that wasn't the killer. This was. The control rods at Chernobyl were not simply columns of boron. Each rod had a graphite section attached below the absorber, a displacer there to push water out of the empty channel and make the rod more effective when it was withdrawn. The lengths were wrong. When a rod was pulled all the way out, the graphite displacer sat centered in the fuel region of the core, with about 1.25 meters of water above it and the same below. So picture what happens when that rod starts to fall. The absorber comes down from the top. Good. But the graphite comes down too, into the bottom of the core, shoving out that column of water. Water that was absorbing neutrons. You have just added a neutron moderator to the bottom of the core and removed an absorber in the same movement, in the same instant. For the first seconds of an emergency shutdown, the RBMK's safety rods increased reactivity in the lower part of the core. They gave it a name, a positive scram. The emergency stop had an accelerator built into the first stage of the pedal. 3 years before Chernobyl, at the Ignalina plant in Lithuania, engineers commissioning an RBMK hit the scram button and watched the power go the wrong way. They found it, they characterized it, they understood that the size of the effect depended on how the power was distributed through the core and how the reactor was being run, which meant it was worst in exactly the conditions reactor number 4 was sitting in on the 26th of April. There was an intended fix, and it wasn't even expensive. Restrict how far the control rods could be withdrawn. Never let them come all the way out. Keep the graphite from being able to make that plunge. The restrictions were never imposed. According to the International Review, the matter was apparently forgotten. The design flaw that destroyed Chernobyl was discovered, documented, understood, assigned a solution, and then it evaporated inside a bureaucracy, and the men standing at the panel at 1:30 in the morning never heard a word about it. They were operating a reactor whose emergency shutdown system could, under their exact conditions, do the opposite of what the label said, and the label was the only information they had. Everything up to this point has been set up. Here's the 40 seconds. 1:23 and 4 seconds. The turbine stop valves close. The test begins. 4 of the 8 main circulating pumps start to slow, powered by the coasting turbine. Poached here at the Hilum, Thorfnesborn. For the next half minute, nothing is wrong. This matters more than anything else in this video, so I'm going to be precise. The Soviet State Commission report annexed to INSAG 7 states that during the rundown, the parameters of code, the unit stayed within the limits expected for those operating conditions and required no intervention by the personnel. The test was working. 1:23 and 40 seconds. The shift chief calls for shutdown. A Z5 is pressed. Why? The commission that spent years reconstructing this could not answer that. Their report says plainly that they were unable to establish why the button was pressed, and they say something more damning first. From the start of the test until AZ5 was hit, no reactor parameter required any intervention by the personnel or by the safety systems at all. Dyatlov, the deputy chief engineer, gave the only explanation that has ever really made sense. The job was finished. You shut the reactor down when the job is finished. That's the mistake. That's the entire mistake. Two men decided to switch off a machine at the end of a test. The rods begin to fall, all of them from the fully withdrawn position in a core with 8 rods of margin at 200 megawatts, saturated with xenon. The graphite goes in first, 1:23 and 43 seconds, 3 seconds. The power excursion emergency signals fire. Power blows through 530 megawatts thermal and keeps climbing. Fuel elements rupture. Shattered fuel dumps its heat straight into the coolant. The coolant flashes to steam. The steam removes more absorber. The power climbs faster. Damage to 3 or 4 fuel assemblies would have been enough to destroy the reactor. Far more than that went. 1:23 and 47 seconds. Coolant flow readings go wild. Pressure in the steam-separated drums spikes. 1:23 and 49 seconds. A signal fires that no operator ever wants to see. Pressure increase in the reactor space. Rupture of a fuel channel. Then the reactor support plate lifts. 1,000 tons of steel. The control rods jam. They are roughly halfway down. Halfway. The scram never completed. In the whole sequence, the rods went in far enough to trigger the explosion and not far enough to stop it. 1:24. The chief reactor control engineer writes in the log that there were severe shocks and the rods stopped before reaching the lower limit switches. The first explosion is steam. 2 or 3 seconds later, a second explosion, most likely hydrogen, generated by superheated zirconium fuel cladding, stripping oxygen out of water. The roof comes off. Fuel, graphite, and structural steel are thrown into the open air. The core is now exposed to the sky. Valery Kudemchuk, a pump operator, is killed instantly. His body is never recovered. He is still in there. Another worker dies in hospital of his injuries hours later. A first group of 14 firemen reaches the site at 1:28. 4 minutes after the explosions, they are fighting a fire on a bitumen roof next to an open reactor core. They receive the highest doses of anyone at Chernobyl. Of the roughly 600 workers on site that morning, 134 developed acute radiation syndrome. 28 of them died in the first 3 months. Both men most closely associated with pressing that button, the shift chief and the senior reactor control engineer, died in May of that year. Pripyat, a city of just over 49,000 people, was evacuated on the afternoon of the 27th, around 36 hours after the explosion. They were told it was temporary. Roughly 5,000 tons of material were dropped onto the open reactor by helicopter. Boron carbide, lead, sand, clay, dolomite, across some 1,800 flights. And then the Soviet Union looked for someone to blame. In 1987, plant management, including Dyatlov, was convicted and sentenced to 10 years. That same year, the first international report, INSAG-1, put the primary cause on the actions of the operators: discipline, rule-breaking, men who violated procedure and paid for it. Then the Soviet Union collapsed, the archives opened, and Soviet engineers published what they'd found. In 1992, the International Advisory Group issued INSAG-7, and it reversed itself. The emphasis moved off the operating staff and onto the faulty design of the reactor's control rods and safety systems, and onto the failures of regulation and management running through the entire Soviet nuclear industry. The men who were prosecuted were operating a reactor with a positive void coefficient nobody had explained to them, a safety limit with no instrument to measure it, and an emergency shutdown system with a known defect that had been documented 3 years earlier and then lost. Dyatlov spent the rest of his life arguing that point. He died in 1995. In 2016, A steel arch weighing 31,000 tons was rolled into place over the ruins of Reactor number 4. The new safe confinement, over 2 billion euros, 45 countries, designed to hold that core still for 100 years. On the 14th of February, 2025, a drone struck it and punched a hole through the roof. In December of that year, after a full assessment, the International Atomic Energy Agency stated that the structure had lost its primary safety functions, including its ability to confine. The plant's director said full restoration could take 3 to 4 years. 40 years after 2 exhausted men pressed a button marked "Emergency Stop," the thing they exposed is sitting under a damaged roof, and there are people whose entire job is to keep it covered. The lesson was never that operators are dangerous. The lesson is that a safety system nobody has told you the truth about is not a safety system. It's a trigger with a comforting label on it. They pressed the button they were trained to press. The button was the bomb.